So I am just going to share my screen, then we begin. Oh, Um, today I am really excited to be here today, and if you have any questions along the way, just kindly put in your questions in the chat, or you can just raise your hand and then I'll call you to ask your question. So I think my introduction has already been made clearly. My name is Benis and I'm currently a final year student at African Leadership University. I'm specializing in machine learning and AI, and today I will be taking this workshop on the art of exploring data, exploratory data analysis and visualization in Python. And today it's going to, as we all know, it's going to be 2 days. So today we would just majorly be looking at pandas and trying to do data manipulation using pandas. And then tomorrow we would finalize everything with visualization. Probably by the end of today, you get to know why it is important for you to know EDA, or for you to be able to analyze your data, and why it's even necessary in the first place that WiDS Accra decides to organize a workshop such as this. So I'll just go right into it. But before I begin, I just want us to maybe in the comment, just let me know how you are feeling and how expectant are you for today's session. So I know that we can all hear me and we are following. So in one word, just tell me how you are feeling and how expectant are you for this session. Hi guys. Great. Thank you, friends. I'm excited. Great, excited. This is going to be okay. Sorry, I'm just going to read. Excited. This is going to be highly educational, ready to learn and unlearn. Let's keep it coming. Excited to be here. Alex, Lisa, Bridget, ready to learn. We are 26 on the call, guys. I mean, EDA is fun, so let's let our energies be also high a little bit as we anticipate the session. So, guys, let's keep it coming. Maybe two more, and then we just go into the presentation. Excited to learn, Rabia too. Okay, great. Sharif, excited to be here. Thank you so much, guys, for um, sending in your expectations and how you're feeling. I will just go right into the presentation. So today I will be presenting in twofold. So I'm just going to give us an overview of what we should expect today, and then we'll go right into the notebook. I mean, Python and Pandas is not with slides, but you get to do the work itself. So I'll just take us through the slides, and then afterwards we'll move into the notebook, and then we start coding. Um, I already introduced the topic, so we'll just go right into it. Today we'll be looking at introduction to exploratory data analysis. Why do we even have to learn it? Why is it important? And then we'll look at loading and inspecting data. We'll look at data cleaning essentials. We'll look at filtering, grouping, and aggregation. Then also we'll do a very simple project on what we've learned today, because Today we are taking one thing at a time. We'll do this today, then tomorrow we'll dive into the next part. So today we are doing data manipulation, which is part of EDA. And then tomorrow we'll do data visualization, which is also another part of EDA. Now, what is exploratory data analysis? So EDA is basically the process of examining or understanding your data and extracting insights to identify patterns or main characteristics of data. So it's basically like maybe you are trying to do something related to, say, let's say blood pressure. You're supposed to predict the blood pressure of patients, right? And then they give you the data. You can't just start, okay, maybe training your model. You just start doing all of that. You need to understand the data. You need to understand what do I have in the data, what is being given to me, and how do I develop on that to be able to use it to do something meaningful. So mostly when you look at the data pipeline, what you start with, the pipeline of probably a machine learning model is mostly starting with data. And then with the data, they talk about data collection and all of that. So if you collect your data, the next step is trying to understand the data. With this data that is being given it to me, what will I use it for, or how useful it is to you. So this is basically what EDA is about, exploratory data analysis. So as we can see, the name is what? Exploratory, and then we can see explore in there. So you are trying to explore your data basically. There's no long explanation too much about it, but it's just trying to get insights out of your data, and then you use it to build whatever that you want to use it for. Or you can also use it to inform decisions as well. So it's not all the time that the analysis of data might lead into training a model. Sometimes it's just needed to be able to make decisions in companies or in various places that you may find yourself. So as I said earlier, as we can see in these diagrams, please let's give a thumbs up if we can see the diagrams clearly. Great, thank you. So if you see in the first diagram, we have data cleaning, we have data preprocessing, we have data insights, visualization, and report. Just as I said, when you start trying to do a project, let's say an AI project, the first thing that you do is that you get your data. And after getting the data, you don't just take it like that, and then you start building models or trying to build the next big AI project. You start from somewhere, and that is from what? Cleaning your data. And that cleaning of data and then pre-processing is just trying to make sure that your data is ready. There are no null values, there are no missing things in there that will prevent you from building a bias model. If I mean a bias model, a model that it doesn't fit into the context that you are trying to build. So you are just trying to prep the data to ensure that whatever that you are building is being useful and it'll be able to serve the purpose that you want it to serve. And then you also see that data insights. So as I explained earlier, it's sometimes you just need to analyze the data to make decisions. Just so maybe you are the data analyst of your company, and then there's something, let's say a supermarket or something, or a pharmacy, and then you have so many pharmacies across board. We are trying to analyze the data on all the various branches of the pharmacy to see which pharmacy is probably performing well. And then you try to do some metrics to see which one is performing low, why is it performing low, and all of that. So in that context, you are not trying to build a model, but you are just trying to understand the data to be able to make informed decision on how to probably increase sales and all of that. So basically that is what you can also use data analysis for, exploratory data analysis for. And then also visualization, which we'll be doing tomorrow. Some people always say that it's better to see it was visually, like enough of the quotes and the text and everything. You want to see the graphs and everything moving. With that, it's more appealing, and then you're able to even understand it better. And then the report part of exploratory data analysis. If probably you are the data analyst of your company, and then they ask you to analyze the data. At the end of the day, you can't just send your notebook. You say, oh boss, attaches my notebook. You can't send that to your boss. You have to put it in a format that they'll be able to understand. So that is where the report comes in. So every EDA should end with a report and an understanding of what you've been able to do. Thumbs up if you're following so far. Okay. So steps for performing exploratory data analytics, I already mentioned that. So you understand your problem, import the data and inspect, handling missing values, explore data characteristics. I'm just going to brush through them because we'll be doing it further in the notebook and trying to understand. Then we have the types of EDA. We have what? Univariate, we have bivariate, and also multivariate. So univariate is basically just one. So you see we have histograms, we have box plot. Let's say we have age. So the age is like a feature. So the column names in when it comes to AI and ML, the column names that you have, let's say you have age, height, and all of that, those things, we call them features. So the features that, let's say you have those features, age, height, and everything. So when you're building a histogram, you try to build like a histogram for age to monitor the trends and how everything is being shown. You don't need two things to be able to do that. So in that context, you're just looking at one variable and you're trying to make sense out of the variable, and then you identify the trends in that thing. And then for bivariate, you're trying to find the relationship between two things. So let's say maybe the age and let's say the weight or something. So you're trying to see how weight correlates with age, like what are the relationships that they have in common. If age is higher, is weight higher or is weight lower? So in that context, you're trying to compare two things. And then multivariate is just trying to look at like your whole data, maybe like 4 to 5 features. You're trying to study all of them at once to find out the trend in the data set. So basically, this is what you need to know about EDA. And as I've been saying earlier, EDA is most of the fundamental things that you need to know. Like you can't just start building an AI model or building the next ChatGPT if you can't do EDA. No matter what you are doing, it always starts from EDA. So there's no way you grow out of EDA unless probably you get into a company where there are so many like AI guys that maybe you have a data analyst, you have a data engineer. In that sense, you might skip the role. You might skip the roles. Maybe the data analyst will pass it on to you as the ML engineer, the machine learning engineer, to build a model directly. But if you're in a company where you don't have all of those employees, you have to start from scratch to build. So it's very important that you understand these things to even inform how you are going to train or build your model. Okay. Sorry. Yep. So now we are going to go into pandas. So pandas is just an open source library for data manipulation and analysis. When I started, I was like, today we'll be doing data manipulation, and then tomorrow we are going to be doing data visualization. Data manipulation is basically just trying to tweak things, trying to check things. You know, you're manipulating, you're trying to find out things. What is the mean? What is this? What is that? So it's like you're trying to query the data to find insights out of it. In that context, you are not necessarily building a visual, but you are just trying to find insights out of the data, the rows, the columns, what is it, and all of that. And mostly, what pandas does, what we know pandas majorly for, especially in this AI and data science industry, is mostly about data frames. You want to put your data um, in a form that you are able to easily interpret it. You want to put it in a form that you are able to easily analyze it. So in this context, pandas mostly helps you to put your data in a tabular format, which we call data frame. So mostly you would see that in most contexts when you start, if it's not, let's say, a speech or a text, something that you are trying to build, even with that, sometimes you still have to change it to a data frame to find insights out of it. And then afterwards, you send it back into the normal format of it to be able to analyze data. I wish I could show you guys something, but I'm not sure if I still have it. But basically, this is, let me see if I can find something for you guys to just show you how important um, EDA is and data analysis is before you build any model. So, okay, I'm coming. I'm just trying to get a notebook and then show you. Mm. So I'm going to share a different screen and then I just show you as quickly what I'm showing, what I'm trying to point out, and then we move. Okay, I think this is it. Sorry. Okay, you can see my screen, right? So this was a finance QA chatbot. So it's supposed to answer finance related questions. And then when you look at it, if you look at this place, it started with trying to change the whole thing into a data frame. In this context, this is how a QA, when you're trying to build a chatbot that answers question and answer question that answers questions, this is the format in which it comes in. But for you to be able to effectively analyze it without difficulties, it's always advisable to change it to this format, this tabular format, to be able to use. So this was just to help me get, you see, I'm looking for shape of data, I'm looking at the unique things in the data. So this was just to help me effectively analyze my data before I start training the chatbot. So you see that from here, I had to change it back to this format so that you see, I had to change it back to this format so that I'll be able to use it effectively for my chatbot. But in the initial stages, I had to change it to a data frame. So regardless of whatever that you are doing, whether you are doing like whatever that you are doing, you always have to come back to EDA. So let's take it as something very, very important. We'll just go back into our slides. That was just to show us. Then we move into so I mentioned earlier, I took us through the outline of everything. So we'll be looking at just loading and inspecting data. So this is just basically how we'll be able to load. You have data in Excel sheet, you have data in different formats, JSON files, you have data in TXT. How do you import it into Python and Pandas to be able to use it effectively to make your analysis? So we'll be looking at that. Then also we'll be looking at cleaning, data cleaning, how to handle missing values, how to drop duplicates, removing and modifying columns as well. Maybe you are building, you've collected data or you have a survey data, but there are some unnecessary columns that will not contribute anything to your analysis. It's better that you put it aside and then you're able to go forth with what you have to be able um to make good analysis of your data. And then we'll also be looking at filtering, grouping, and aggregation. We'll try to filter rows, maybe out to get into rows and really understand what is inside each row. Grouping data, maybe you are trying to group, maybe let's say you have let's see, middle class income, high class, and lower class, and then you're trying to group these data. How do you do that? How do you just write a single line of code to be able to just group it automatically? We'll also be looking at that, and also how to aggregate your results. Then we'll also be looking at value counts. How do you find more insights? Let's say you have categorical, you have people, let's say classes like the lower class, upper class, and middle class that I said, and then you are trying to group these data. You are trying to find the people that are in upper class. You are trying to find the people that are in lower class. How do you just write a single line of code that you'll be able to do that? And then this will just be basic feature engineering. We'll be looking at creating columns, applying functions, categorizing continuous values with this, and then string operations. Then we'll just do a mini project. A spoiler is that Pandas is so broad that every day you will get to learn something, like literally every day, depending on what you are doing, you will get to learn new thing, something new in Python. So we might not be able to cover in depth into all that it is in Python, but I'll try as much as possible to cover at least the basic ones, such that we'll be able to at least analyze a simple data or manipulate a simple data today. So please do we let's give a thumbs up if we have Collab and we have access to Collab. Or if we know Google Collab. Okay, I'm going to do that right away. So we are just going to start from here. So Google Google Colab is basically an environment where we write Python code. Okay, Seth, I'm just going to take us through from there. We'll start from the Google Colab, then we move into the code. So Google Colab is basically an environment where you are able to write and execute code. Majorly it's used for data analysis. It's mostly used for data analysis. You use it to analyze your data, use it to build models. It's used mostly for AI stuff, and that is what Google Colab is. So there are other environments that can be used to do this. We have another environment called Jupyter Notebook, which you can just download it and then have it on your local computer to use. But probably after this session, I can send in the link for us to download that. But will not be able to download it. So today we'll be using Google Colab environment to run our codes and then effectively analyze our data. So I'm just going to send this link, or you can just type in your browser Google Colab, and then you would be able to go into it. So let me just send us this link, and then you will just go straight into it. So you don't have to download, you just have to. Yeah. So you can just, let's click in and follow. So just click on the link and then you come to an interface such as this. Please let me know if you are doing it and you're following. Okay, just one person. I think set two. Okay. Okay. Those that didn't have, I think I saw Samuel, I saw Akon, Set, they didn't have. Okay, great. So now when you just come here, you see something here called this new notebook here, this thing. So you just click on this, and then you would be able to open a notebook. So basically, this is how everything is like. Let's confirm if we have been able to get here. Great, thank you. Great, great, thank you. So now I am going to share a data set that we'll be using for this class so that we'll all be able to follow along. So we'll actually be using several data sets, but I will just send you all the links and we would see how we'll be able to download each of them. So this is a Google Drive where you'll find this first file, this first data, which is Google house pricing data. So let's just download that data as well. Please let's confirm if we've been able to download it. Okay, Elizabeth, or it's a mistake? Okay. Okay, then I'll just go straight. So now we are going straight into our codes. So here, if you already have your data downloaded, you will just, so this is basically how the interface of the Google Colab looks like. This is like a file. So the notebook is like just a file that we use in analyzing, like most data analysis project is always in this format. It has the cells, this thing here is called the cell. So it's the cell in which you input your codes and do everything in it. And then you can either have a code cell or you can have a text cell. So here, this text cell is like a markdown. So markdown is basically writing code, like writing text when you're writing code. So in the midst of codes, whatever that you put in here, this text in here is basically a markdown. So sometimes you can use a markdown to explain our codes or just probably to add titles to our notebook to help people understand more. So basically this is how everything looks like. And then so if you already have your data downloaded, you will simply just come here. This, you see here we have files. This is files. This is like refreshing. This is a drive. And then this is just hidden files. Maybe if you decide to hide some of your files, but this is hidden files. But here, if because we already downloaded it, we have the data in our local computer. So we'll just come in here and then we upload the data. Thumbs up if we are following. Okay, I am going to take it again. So this is the interface that you have, right? This is the interface for writing your codes. So this is called a notebook. So we are writing it in a Colab environment. So it's called a Colab notebook, right? Google Colab notebook. So this is where we'll be doing all our analysis on, and it's called, most data analysis projects are being done in notebooks. So basically this is what, like, this is all you need to know. So it's just like an environment or a place in which you are able to execute your codes very well. So this is how everything looks like. And then now we are just going to upload our data into this environment so that the analysis that we are going to do, we'll be able to do it, because we can't just do normal analysis without having data, right? So you would come here, you see we have files here. So you would come here and then this thing represents upload. You come here and then you click on this thing and you select the data that was downloaded, and then you click open to upload it. So I'm just going to, I already did, but I'm just going to upload a random data. So let's say I'm going to upload this Pokemon data. So I just click on it and then I click on open. Okay, Esther, go ahead.
Thank you very much. Sorry. So I don't know if it's just me, but I only have an empty interface without the symbols, the loading, the upload symbols, and that the rest. So I don't know if you could open a new notebook and start from there. Yeah, just like this. Yes.
Sorry, I was speaking on mute, but you can see this, right? This part.
Yes, I can.
Yeah, so you click on this
Okay.
and then you wait for it to connect. Can you now see it?
It's still connecting, please.
Okay. Okay.
Okay, now it's here.
Yeah. So now you will just come in here.
All right. Yeah, I can take it from there. Thank you.
Okay. You're welcome. Um, please, is anyone having an issue with the loading? Anybody that has an issue with the loading? Thumbs up if we are all on track with having our data. Okay, thank you. So now let's make sure that we upload all the two data sets, the house prices and the Netflix data, because that's what we'll be using for our analysis here. So let's make sure that we have that. So now if we have that, you can just close this thing for now because you might not need it. But if you have that now, we'll be doing what data manipulation using pandas. And in our outline, the first thing that we are going to do will be importing the data. But there's something that we have here called what? Importing necessary libraries. Python libraries are basically pre-written. Sorry, Joseph?
Please, I think we don't have the access to the Netflix data thing.
You don't
So
have
maybe if you
access to
can.
it? Okay, let me try to give you access. Can you see something like this? Because I've given everybody, anyone with a link. So when it opens like this, you just come in here and download. Has
Okay, I
anybody
have
been?
it now.
Okay, great, great. Thank you. Great. So we'll just continue. Any other thing with any other questions with the data, uploading the data on the Google Colab? Do we have any other issues? Going 1, 2, 3. Okay, then I would move straight. So we have the data manipulation using pandas, and the first step that you would ever want to do when when trying to build anything, trying to analyze your data is first to import, because you can't, as I started earlier in my slides, I spoke about pandas. You cannot start analyzing your data or start reading anything without having pandas, because basically all that you are going to be doing will be related to data frames, and then data frames is linked to pandas, which is like the basics or the starting point of getting to understand your data. So the first thing that you would want to do is to import your libraries. So libraries are just pre-written codes, models that provide functions, classes, and all of that. If you have had something to do with Python a little bit, you would get to understand what functions are, what classes are, and all of that. So libraries are just like a combination of all those things. So instead of you to start writing a function, start defining classes to be able to put your data in a tabular format, pandas has been created such that you don't have to go through all that route of building functions and classes to help you maybe just load a simple data or just put your data in a tabular format. So basically that is what Python libraries are. And so for today, in our first step, you would want to import pandas, and then you would also want to import NumPy. Now, sometimes people always have this question, import pandas as PD. Is it compulsory that I put PD? It is not compulsory that you use PD, but it's like something that has become accepted and is part of the whole pandas thing. So anybody that is importing pandas imports it with PD. But if I decide to change this to, let's say, ND or something, it's still going to work, because you're just trying to just bring pandas, you are importing pandas, but you want to use it as PD. So wherever that PD is being seen, Python reads it as pandas. So basically that is it about import and then trying to understand what Python libraries are. Thumbs up if you are still with me. So we'll just do this. Thank you. So today we are not doing visualization. We are not doing anything complex. We are just dealing with pandas, and we might not even use NumPy, but let's just import it, because NumPy is for mathematical computations when you're trying to deal with serious mathematical computations in data analysis or in ML, mostly when you are going deep into machine learning, trying to do linear regression stuff and all, you would have to use NumPy along the way. But in our workshop today, we'll be dealing with only pandas. So let's just quickly import pandas as PD and then import NumPy as NP. Let me know if you have this, if you've been able to get this. Great, thank you. So I realized that some of us are beginners to Google Colab. So after you've written your code, to be able to run it, to be able to execute or run it, such that it's been recognized by the environment that this has been imported, you have to click on this play icon in there. It represents run. So you see that when I put it, it was run cell. Cell might have changed. So run cell, whatever. Like run cell might have changed. It's like maybe you change the cell. So they're just trying to tell you that run it if you have changed any code in it to be able to be recognized by the environment. So you just click on this place. And then when it gives you that green mark without any red thing, when it's red, you have to start crying or start probably checking out what is wrong. But you would always prefer that it marks and it executes successfully. So straight we will go into importing the data. Also, as you saw in here, it's not all the time. If you don't like to always, what do you call it? If you don't like to always click in here, you can just use your keyboard and then Shift plus Enter. Executed. Dear Frempoma, please go ahead.
Yeah, sorry, my network got disconnected a bit. Could you take it over again, how you imported it?
The data.
Yeah.
Okay. Sorry for us ahead. Let me just quickly. So you would have this interface. Confirm if you have this interface.
Do.
You do?
I have uploaded it, yes, I have uploaded it, but then just like for some few seconds, I can see the Netflix on the coding aspect, like that.
Yes, here.
Yeah, from the importing data down there, I could see Netflix data.csv.
Is it here?
Yeah.
No, so we've not gotten there yet.
Oh, okay. Sorry.
Yeah. Okay, no
Okay.
problem. Yeah. So here, we're just moving into that. So the next thing is importing data and then trying to make sure that you have this data in your cell, or it's being recognized such that you'll be able to go ahead with your analysis. So here we are just trying to set the data part. There are two ways of doing that. We'll get to know that, but here you can, if we've learned Python, obviously. So in Python, you see that this is like defining a variable. So I'm setting a variable to this, so that when I just call in this data, Python knows that I'm trying to call this thing. So from here, how do we get, so let me just get this. So here, how do we put in, or how did I even get that link or that part? So let's say I'm trying to define my data as I'm trying to define my data as the part that I have here. So you would come in here where you loaded your data, and then I'm going to load the Netflix data. So you come in here and then you see these three dots, right? Then you click on these three dots and you see copy paths. Then you just copy the path. So I'll copy the path in here. And we know that when you are saving letters or things in Python, you put it in a string format. So I'm just going to bring in my quotations and paste in the part that I copied here. Thumbs up if we got that, or we got lost within the way. Great.
Please, I think you see, from the first one we use, when you are moving into the next one, I don't know whether it's coming to be in the next part. You see, we have a portion where it seems that it is divided from the first one.
This one?
Or this one is, yeah.
Is it a code?
Yes, please.
Is it the cells? Yeah. So when you finish the first cell, I'm just going to take. So you see when you, let's say I have import pandas here. Now you see that there's
They
nothing
want to
in
move
here.
to the first cell. Yeah.
Yeah. So when you want you see, so you just bring it like closer. Then you decide on which one, whether you want to write a code or you want to write a text. So you just click on
okay.
this code.
Oh,
Then
okay.
you move. If I also want to do a text, I can just do markdown. So let's say loading data. If I want to add captions, so these ones you can decide to make it a heading, bolding it, italize, do whatever that you want to do, maybe add list and all. So this is basically the markdown and how everything works. We are on the same page. Are we on the same page? Okay, thank you. Moving on. So let's confirm if we got how to get the path and then load the data. Okay, thank you. So now we are going to finally load it into our data. This was just like normal Python stuff. I defined a variable in this context. But in the next one, we are trying to now load the data that you have here, and the data, the variable that you have stored. You are trying to load the content that is inside the variable. So in loading in loading files, there are different file extensions, if we all know. Can we just in the chat mention like any file extension that you know? The various file extensions. You can either unmute and talk or just type it in the chat. File extensions. What are the various file extensions that you know? Anybody that wants to help me out, or I should just call someone? Oh, okay. I'll just go. It's like nobody wants to mind me. I'll go forth. So we have different files. We have CSV files, which represents comma separated files. So you see when you downloaded the data, let me see if I still, yeah. So you see so these are, because it's opened in, what do you call it? Because it's opened in Google Drive, is just structured. But let me see if I can open it. Okay, let me share the screen and show you how everything looks like in a normal, in how it looks like as a CSV, as a comma separated file, and why we even need pandas to be able to load it. So this is my VS Code, and VS Code is also another environment just like Google Colab. So you can see how the data is looking like. If you see this data, you wouldn't even understand what this is. It's going to look so much in your eyes, like it's looking so many, like so much. You don't even understand which is which. So that's when Python and pandas comes in to structure this data such that you'll be able to use it for all your analysis stuff. So basically, I just wanted to show us how a CSV file looks like. Yep. So the first file extension that we'll be trying to do is a CSV file, which is like one of the common, it's not even one, it's the most common file extension that you ever see in most data sets that are being given to you to analyze. It's always going to be in CSV. Like, let's say 80% of this time is going to be in CSV, especially when you're dealing with EDA and all of that. It will only change when you have probably moved into text, using text to build models, like the QA chatbot that I showed you. Mostly it's in TXT format. So basically, This is how it is. So to load a CSV file, which we have, it's going to be the syntax. So to load a CSV file is so you define this df represents the name that you want to give to your data set. So I defined it as df. It's just like a short form of data frame, but you can decide to name it anything. And then you do PD. Remember that we imported pandas as PD. So in this case, you're importing this, you imported this as PD. So you're calling pandas in here, and you're telling pandas that read this CSV file, and then you put this thing here. So you remember that this data represents this content. So this is what you would put in here. Let's thumbs up if we are on track with this. Great. So now afterwards, you will just run it. And another thing too is that we are going to comment this out. It's not all the time that you would want. Sometimes maybe you don't want to define it as a variable before accessing it. You can just do df equal pd dot read underscore csv. Then you copy this part that you have in here. You can just directly input it here. So instead of setting it as a variable and then accessing it, you can just put in here. So I'm going back to copy the part of my Netflix data, and then I'll put it here. When I run, it will also work. So basically, you can decide to set it as a variable, then you access it, or you just pass it in this way, and it's also going to work. Thumbs up if we are here with me. And then we have, thank you. And then we have this. This is also for Excel files, how to read Excel files. And then you see that the only difference we have here is that instead of CSV, we are putting Excel in here. I didn't send this data because we will not be using it to do the analysis. But if you always see this XLSX, this file extension, that's the file extension for Excel files. If you always see this thing, remember that you cannot use read underscore CSV. You have to use read underscore Excel because it's an Excel file. If you use read underscore CSV, it's going to give you an error because Python will not understand, because you have CSV here, but your extension doesn't correspond to a CSV file. Okay, Joseph, go ahead.
Okay, so please, with the where you were declaring the data to be the part,
yes,
where you were assigning the part to the data, this thing. So if the third one, if you are using the second steps, then that there's no need for you to declare it in the second.
Exactly.
Okay.
Yeah, so you see here, I didn't declare it. I just put in the part.
Okay.
Yes.
Right.
So you don't have to. It's maybe when sometimes people just want to organize their work and make it look really cool. So they decide to define variables for everything and then just access them. But you don't have to do all of that. You can just pass it in. So I'm going to do something. I'm going to change this Excel to CSV. Let's see if we are going to get it right or not. So you see, can't UTF, can't codec, can't decode, bytes, whatever, syntax, bytes. So it's not, you see, we are even here, pandas.libs underscore passes text reader. So you cannot read it because what you are passing, the syntax we are using doesn't correlate with the file path you have in here. So let's always ensure that when you are trying to load your data, you are looking at the file extension, and then you find the right syntax to use in loading your data. So these are just other ways. This is txt file. These are just ways of loading txt files. So let's say you have a book in that format, is in that writing format, paragraph format, and then you want to load it. To be able to access it, you have to use this txt thing. I think I didn't even write the right thing. So yeah, it has to be txt. So yeah, you see that it's even wrong because I used CSV. I used so now yeah. So can is this, if I'm to load this one, is this going to work or it's not going to work?
It's not going to work.
Yeah. Any other person, whether it's going to work or not? So apparently it's going to work. So this is because you see, okay, Sheriff, go ahead. Sheriff, you are muted if you're talking.
Yeah, it's going to work. Hello, can you hear me?
Yes, yeah,
It's going to work. I think the other argument, that's it. Is it delimiter with
yeah,
a slash T? It's like a tab to shift it forward, something like that.
exactly. So it's going to work because this so sometimes it can be delimiter or it can be something like it can be something like, let's just define it again, txt call pd.read. So sometimes it can be something like the sep. So this thing is like a separator kind of thing, and then you would still do it by this thing, like this character. So this is what makes it different. You see, if you remember, when I showed you guys the CSV file, it comes in the comma thing and all of that. And then if you look closely at txt, it basically comes in that format, just that sometimes instead of the, you see for CSV, it has shorter lines. Maybe it's just named comma this, but in TXT, the sentence can prolong. So this is just to cut the thing short, and then you'll be able to use it. And then here, this is just for loading JSON files. If you deal with JavaScript, JSON files is basically like dictionary format data sets. So to be able to load your data in the form of a JSON, to load your JSON file in a data frame format, this is the syntax that you are going to use. So you can see that the difference is always with this JSON thing. You are changing it into this is what the difference is. You see here we have CSV Excel and then we also have JSON, but with this txt file we have this delimiter separating it. Great. Thumbs up if we are okay with this with the yep, thank you. So now we are just going straight into our analysis. We have already loaded our data, so now we are trying to so you see we loaded the data but we didn't print it or we didn't do anything with it. We could have just printed it. It's going to work. Let me print it here. So let's say I do print df, right? I can just do print df. So it's going to work, but you see how it's been shown. It's not nice. Or you can just do df and it's also going to work because it's a variable that we are defining, right? So we are just going to do it this way. But you see that when you are, it's always difficult to, when you are, sorry, when it's in the normal CSV file, it's very difficult to be able to navigate into the data. You're trying to put in something that is very complicated to understand. But when it becomes when it comes in the data frame format, you can see that it's being structured in a table format. So you can clearly see there are indexes in here. You can clearly see that it's being structured in the rows and columns format. So it's easier for you to understand. So let's say you see there are how many data sets? It's about 11 columns, 7,787 rows, 11 columns. So I just want to view, let's say, a smaller part of it. I'll just do df.head, right? And this df.head represents you trying to view from the beginning. So you're trying to view from index 1 going downwards. So in that case, you use df.head. I'm just going to do it from here. So df.head, then you pass it, and then it's just going to print out the first 5 data that you have on your data set, the first 5 columns that you have on your data set. First 5 rows, right? Yes, rows rather. First 5 rows that you have on the data set. So basically that's what it does. But if you want it to print out from downwards, maybe you view the first part and you're also trying to view what the back part is going to look like. Maybe starting from the last part, you're trying to view how it's going to look like. You use the tail, so it's like head and tail. So you also do df dot tail. Then you put 5. Then it views from down upwards. Another thing to also notice that this can be anything depending on like how much data you want to view. You can always change it to anything at all that you want it to view. So basically, this is how it looks like in that format. Have you been able to view our data? Okay. So now we would move into we are progressing in analyzing our data. Here we'll be looking at the shape of the data. So the shape of data is just trying to tell us how many columns do we have, how many rows do we have. That's basically what shape does. So here you just do df.shape and then it gives you the number of rows and then the number of columns. So when I do it, you can see that I have this one representing the number of rows and then this representing the number of columns. So basically that's what data.shape does. And then we have checking for the columns. So now I've checked for the shape. You see this, I have to now scroll like this to check for, imagine if I had about 30 columns. It means that I have to be like trying to stress myself to get it. But Python has made it easier for us. So I just have to do df.columns and then I'll be able to print out all the columns that I have in my data set. So if I do df.columns, I can just, and then it lists out all the it lists out the names of the columns that I have for me with data.columns. And then we are moving straight into trying to really understand Python functions that will help you, pandas that will help you really understand what your data is about and what each thing is doing. So now we have the data.info. Information. It tells you more about your data sets, like the data types. Anybody that cares to explain to us what data types is? What is a data type? In Python. It's the same in all programming languages. Okay, Esther, go ahead.
Okay, so I believe the data types are whether they are numbers or text or other data types. I don't know if I'm making sense. So literally, some
you are.
can be computations and others can't. So it's just a way of defining your data.
Exactly. You're welcome. Thank you so much. So you see here, I have like integers, floats, strings. All of those things represent data types. It's just basically to know if I have age, is it a string? Should Python see it as a string or should Python see it as a number? If I have date, should Python see it as a date or should Python see it as just numbers with hyphens? So basically, that's what this info tells you, it also tells you whether you have null values. Null values are basically missing values in your data set and all. So to be able to learn more about your data set, which is being coined into .info in pandas, so you just call this the variable of your data frame, and then you do .info to find the information, or to get to know more about your data. So you see here, you see range index 8778, there's 0 to 77, this data columns, we have total of 11, then it prints in the column names, then it tells you the non-null count, then it tells you the D type of it. So objects and strings are basically the same. Then it tells you int. You can clearly see that when you're going to use this to make this date added and then the release, if you're going to use it to make an analysis, you have to change this into a date format, because if you use it as an object or an integer, Python is just going to view it as such. It's not going to see it as a date. So in this, if you want to really progress in using it for advanced things, maybe for modeling and all of that, you would have to change this into a date time. So you change the data type from object or from an integer to a date time data type. So basically that is it. So you can see why it's important that we get to see all of these things and see. It can even inform to us like what we have to do. And then you can see that here we have the non-null things. We have 5398, but in sense it's supposed to be 7787. So it also tells us that, oh, there are some values that are missing. There are some values that are not up to the number of things that we are supposed to expect. So basically that is what the .info tells you about your data set. Then we also have the summary statistics. So this is like the mathematical part. It gives you a breakdown of the standard deviation, of the mean, of the count of things, the maximum and the minimum values of everything. It basically describes your data in mathematical context for you to understand. Okay, sorry. So df.describe also does that. Then as we can see, so one thing that you would also have to realize is that when you are doing this df.describe, you see that when you have something like title, director, cast, and all of that, it's not part of the df.describe because it needs numbers or numerical data to be able to do that. So you see that it only took the columns with numerical things to make the insights out of it, or to help you really get the statistics that are involved. So you see that we have the 20% of this, which is always what lower quartile, right? Then we have the lower whatever that it is, the percentiles of everything. Then we have the STD, which is standard deviation. Then we have the minimum, we have the mean, and we have the count as well. And you can clearly see that this is very fishy, because how do you find the count, the mean of dates? So you see why it's important that it's relevant that your data is always, your columns or your features are always in the right data type, so that you'll be able to, Python doesn't recognize it as something else and then it's giving you different things that you are not expecting. Then here is just to the .df.d type just helps you to print only the data type. So now you just want to print the columns, and then you want to print the various types of each data set. So here, you see that it just shows that to you: object, 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 integer, integer, object, object. So basically that's what the D type does. Thumbs up if we have been able to get the loading and data inspection. Okay, great. Thank you. Thank you so much. So we'll be moving into data cleaning as well on our outline. We'll be doing data cleaning. So I can't even emphasize on how important it is that you are able to use the right, like you're able to ensure that your data is so clean before you start using it for anything. Because if you don't start with that, you are going to encounter a lot of errors along the way. So it's always important that you make sure that your data should always be clean when you are working with it. So now first in data cleaning, we'll be looking at missing values, because you don't want to be using empty boxes to be building models. If you use that, it's going to be biased. Your data have empty things. Sometimes it will not even execute. You might not be able to train your model or go forward to train your model. If you have empty things in there, you would encounter some errors, because not all the data sets is present, and you'll be having none. If you check the data set earlier, you see we have none and all of that. It will not be able to, like, it will not be recognized. So what is none representing? In that sense, even if you are making decisions out of your data, you will not be able to make a very good decision, because you have things that is not being recognized in your data. So now the first one is trying to count missing values. So the first step that you would want to do is that how do I check out the missing values that I have in my data, right? So you will do df.isNow. So isNow is basically, it's like now in empty. So isNow.sum. So with that, you'll be able to check whether you have, or you count the missing values that you have in there. So you see that we have what, 0000. Then you see initially I was telling us in the info, you could see that it wasn't up to the number of column rows that it was supposed to have. So you can see the number of missing values that we have in there. So we have missing values in director, we have missing values in cast, we have missing values in country, then we also have missing values in the date as well. So these things we have to fix it. So this just helps you visualize it, but it doesn't provide a solution. So it's just like a step to help you see if you really have missing values in your data, and then it prints it out in a simple form that you'll be able to understand and clearly see. Also, you can see that I have or df.isNow.sum. So it's either you do df.isNow, or you can also do df.isNow. .sum. This also works, and it's going to give you the same thing. But you see, I have a question in there. Where's my notes? So you see, I have a question. Why do I have someday dot someday? And what will happen? Hey, what will happen if there's no sum dot sum? Anybody that wants to help out? If I do not have dot sum, what do you think is going to happen? Okay, Joseph.
I think it will just point out just one missing number. But if it's sum, it's going to calculate, you're going to add all the missing numbers in that column or in that row and sum up and give it out a single number.
Okay, so what do you mean by it's going to just print out a single thing without the sum?
So let's say in a director, we have 232,389 missing numbers. But if but if we don't have the sum there, it's going to make it single up to 2,000 and something. You get it? That's my understanding.
Oh, okay. I mean, you're close, like a little close. So let's try it. Let's try to execute it. Thank you so much, Joseph. That was so close. Yeah. So let's do this now. You see. So it's going to return in Boolean format. So it's like you're telling Python that pandas that, hey, check my data set in each of the rows. Check to see if there's a null value. So it's like it's now. If it's now, so it returns a Boolean true, false. It's not now. It's not now. True, it's now. So basically, if you don't put it, this is how it's going to. But if you put the dot sum, just as Joseph said earlier, it's going to put in everything and put it in a format that you'll be able to easily understand. I hope we get that. Yeah, so basically that is it. And then, so now you have observed that you have null values in your data set. How are you going to put them aside, or how are you going to ensure that you don't have null values? One thing that you can do is that you can just drop all the null values. So you're dropping all the rows that have null values in it. But sometimes this method is sometimes dangerous, especially when it comes to maybe building advanced stuff like maybe AI models or something. It's always dangerous to drop the values, because sometimes they might be so important, and then if you remove those values, your data might remain very small. So you have to come up with ways that you are not dropping it, but you are making it relevant by staying, but you are filling it up with something. So I'm not going to execute this because I don't want to drop the null values. Because if you just do this, it's going to drop all the null values in this, and it's going to be 0, 0, right? Maybe anyone can try it, but I don't want to try it, because if I try it, we might have to reset and come back. But let's just finish, and then we can do it all over again and check. But this if you just do df drop NA, it's going to drop all the null values that you have. Another thing is that we have something we call the fill NA. So fill now. So you're filling now. Now this 0 that we have in here is any number that you decide to put in there. So maybe you think that the rows, you can just decide to put zeros for all of them, and then you use it to, you don't want to put a specific number in there. You just want to put it with something. So you can just decide to put everything with zeros, because especially when it comes to mostly one of the dangerous data sets to work with is health data set, because it's very, very sensitive, and you might be killing somebody by putting in zeros or dropping all your rows. So sometimes too, what will inform how you will fill your data is the type of data set that you are working on. It's what industry are you working, like what industry data are you working on? What are the regulations that they have in that industry? So you also want to look at that, but you can also just fill in with zeros and then it will work. You can also decide to try that. But I want us to look at in-depthly into this, because this is one of the things that is being recommended by most people. So don't mind this. I initially had a different data set in there. So now we are trying to, you see that we had director, right? Wait, okay. I know that. I have a question for you guys first, real quick. So now we have director. Can we all see the director column? Thumbs up if you can see. It has names of directors, right? Yep, good. So now, do you think that where is it? Where is it? Do you think that sorry, I'm just trying to go back to where we were. Do you think that with this one, I will be able to use median to do it? Because you can see that we have that director, we have this director color, then we have cast, then we have country as well, which is missing. Do you think that if I'm trying to fill in for director, do you think that I'll be able to use median to do this? Anybody that wants to try, there's no wrong answer. I just want to know our thoughts on it. One going one. Nobody to redeem us. Okay, Bridget, go ahead.
I think it will not work because I
Why?
believe the median, the mode, and those ones are for the standard deviation and stuff. They are for numerical values, and then the director has text like people's names. So I don't know if it will work. I'm not sure.
I mean, you got it right, but you're not just sure. Yeah, that's exactly it. You cannot use summary statistics to fill in this. We know that this median, it all deals with numerical values. So how do you find the median of this thing? It's not going to work because it deals with what? Didn't you define the DF? I did define DF. Sorry, I defined DF. Do you care to talk so that we'll understand your question? Samuel, do you want to understand? To maybe you can type. If you don't want to talk, you can type, and then we'll get to understand your question and answer you. So we are just trying to fill in. Okay. Yes. Go ahead.
Looking at the former one that you assign print, I just want to know the relationship between this DF and then the other one. That's why I was asking, didn't you define it earlier?
This DF, is it this one?
Yes. You see,
Okay.
formally, you wanted to
Mm-hmm.
visualize for the other one where you added print.
Yes. But
Yes.
here I'm having this bracket. Is that a question?
Yes.
Okay, I'm going to explain that. So, you see, so here, this is like, so if you have, let's push this aside. So if you are trying to subset, right? So I have this data. So you see, I had, DF represents the data frame. But if I want to access only, let's say the director column, to be able to subset it, I use this square bracket. And then I put in the name of the column to be able to subset it. So let's say director. So it's for subsetting columns. So basically that's why you have in here. So I just want to find the mean of let's say just the mean of the director column. I can't just do df.mean because in that sense I'm finding the mean for the whole data set. But if I subset it this way, I can just do dot mean, and then it gives me the mean of only that column. But remember, we cannot find the mean of this column because it's categorical. It contains names or strings or text, so you will not be able to find the statistics of that. I mean, let's say I'm trying to find the mean of Samuel Joseph. Like, you have to put it into numbers. So should in case it was in numbers, then I can find it. But in this case, it's in text. And Python, like programming, just follows what you are defining to it. So if you don't tell Python that, oh, Samuel is 1, and you tell it that Samuel, it will not know that Samuel is 1. So you'll not be able to print it out. So unfortunately, in this case, all our okay, Sharif, go ahead.
Yeah, does that mean that the DF square bracket with the directors work like a key value argument, like in dictionaries?
Yeah, something like that.
Okay.
Yeah, so like it just helps you. So, but here majorly is just for subsetting. And I think in dictionaries too, you can use that to subset when you want to call out, let's say the key or the value pairs, the key value pairs. You can use the square brackets to call it out. So it's the same thing used here.
Okay.
Yeah. Okay, so we'll just move in. So now we have the unfortunately, all the columns that we have that have missing values, we will not be able to use this summary statistics to fill it in because it's not now numerical, so we'll not be able to use it to fill in. But we can now go back to this place, right? Because in this case, we know that it's names of people, and we will not, those are like the options available now, and we cannot use zeros because it's not, let's say, how do I put this now? It's not a numerical column that I can put 0. If I add zeros to like text data, it's not going to make sense. So in this case, I would just rather prefer that I drop the all the null values in that columns that we had. So I'm just going to, so I've run this. Now let's do df.is now to see if we will still have missing values. We still have missing values in there. Interesting. Okay, trying to see why df.drop NA didn't work. Let's see something again. So df disappointments of code. Let's see. Still not working. So let's try to figure it out. I have a pandas documentation in here. If anybody also knows why it's not working, you can just unmute and let me know so that we sort it out and move on. Comment. So dropping null values in Python. I'm just going to quickly search it. I'll drop it. Null values in Python. I don't know. So you see, we are having the same thing, but now we have to figure out why it's not working because we have this in there. So this is like the pandas, this one we call the pandas documentation. It contains all the things that you need to know about pandas. You see we have in here the dimensions, we have the shape. It just tells you everything you need to know about pandas. So you see the number of things we have in here. There's just so much to do with pandas. So let's quickly check in why it's not working. So now, okay. So can somebody run it on their end and also confirm if it's not working for them? So now we can also define to drop columns at least one element is missing. So we can decide to do axis column, subset name toy, defining which columns to look for missing values. So let's also try to see if this is going to work. So I'm just going to copy from the Python, the pandas documentation, then we see if it's going to work. So sorry. Okay, so and here we have director. So I'm just going to specify director. When it works, then we do same for the rest. Now let's run it to see. Still, is there something wrong with my has anyone tried and it's not also working? Okay, Rahat, go ahead.
I'm thinking, how about maybe the condition for dropping? If you drop the NA from the data frame, but because you didn't set the in place value, that's why you can still
that in place. Okay, let's see. It cannot. Oh yes, that's true. Let's see. Oh, Jesus Christ. So guys, that was just the problem. So we see what code can do to you. So this is like in place is just like with replace, should I replace everything? Should I remove everything as you have said? So if you set it to true, it just ensures that whatever that you wanted the drop NA to do, it reflects in your code. So basically this is what we were supposed to do, and then the whole thing is going to work. So I'm just going to add, if I add the columns in here, it's not going to work. So I'll just copy this. So guys, let's make sure that we take note of this in place, especially when you are dropping and all of that. Make sure that you have it in there, in place equal to true. If you set it to false, it will give you the same thing that we were experiencing initially. But if you put it to true, it ensures that it reflects in the whole data frame.
Please, can you go over again?
Okay, so what I was saying is that in place ensures that whatever thing that you are doing in here, it ensures that the drop NA reflects in the whole data frame. Do you get? So if you don't put in this, if you don't define this in place to be true, you are going to be getting the same error that I was experiencing earlier. If I define in place to be false, it's going to be that same thing that we were experiencing. But if you define it to true, it ensures that the changes that you made is being reflected in the whole data set. Sorry, does that make sense? Yes, so I want us to try something to see. Okay. I want us to try something with this thing. So let's say I decide to maybe define the data set. Let's say I'm trying to do data underscore drop, and then I want to drop you see we still have cast in this left, country left. So I want to drop the country, and then I do df drop NA, then I do subset equal yeah, so I'm going to do country. Let's make sure that it's all in lowercase. So country. So if I do this, let's see. So I'm going to do data underscore drop dot is not, sorry, dot sum. Guys, can you see something here? It's 0. Can we see the country is 0 here?
Yeah.
Yes, but I didn't define it. I didn't put in place here. Does that ring any bell or anything causing you to question something? Why it worked, although I didn't define it? Okay, Bridget, go ahead.
So I think that when we did data.drop the country, I mean no values in country, we are trying to clear it from the original data set, not the data frame that we created.
Yeah, that's true. That's true.
Exactly. So you see how this thing works. You really have to be careful. If not, you just be getting some errors that you're not supposed to get. So Pandas is so careful such that Pandas doesn't want you to make changes to something, like to make effect to the whole data frame if you don't want to. So this in place equals true is trying to ask you again, are you really sure of what you are doing? And say yes, true, like make changes to the whole data set. But then if I decide to just save it in a different data frame, it doesn't have an effect on the original. So it's like subsetting the data and then making changes to that one. So in that case, you don't have to do in place. But if you want to make changes to the whole data frame, in that case, you have to make the changes with, you have to add the argument in place equal true to be able to reflect the changes. I hope that solves any confusion that we had earlier. Okay. So unfortunately, we don't have numerical columns that are missing, but if should in case you ever encounter any numerical column, you can decide to put any number in here and then you fill it by zeros and it's going to work. Or here you just find the mean and then you do dot fill now. So this fill now just means that fill NA. So for this one, I just wanted us to try it, but unfortunately it's not there. So we can't it's not something that can be practiced with this data set that we currently have. So this is just to tell us that not all the cleaning techniques will be applicable. It depends on the type of data that you are using and when you would have to use it. So these are also just ways of filling in the missing values as well. So maybe you have the data set, but you don't want to start, you want to start filling from backwards, right? So let's say I have let's say I'm just going to do something in here. So let's say my data is 1, 2, then I have NA, then I have 3, 4. Let's say I have NA here again, right? And then so let's take this as the data set or this as the column that I have. So this is just an example. Forget about the DF that we're dealing with initially. Let me just change it into a new place so that we'll get it. So let's say I have this data set, right? And then I have these now values in the data set, but then I want to fill in the values, but I want it to use 2. So I want this thing to fill 2, 2, 2. So the forward fill is basically take the number before it and then fill in all the missing values. Do we get that? For the forward fill. So you use so in this case, we have 2 that is in front. So if I do df.ff fill, it's going to take this 2 and fill in for all the null values with 2. Because it's 2 that is in front of it. And if I do backward fill, it's going to take the 3 and fill it throughout. So basically, that is how this thing works. Maybe you don't want to use summary statistics like mean to fill in the values or median to fill in the values, but you just want to use the immediate things. I think this can work with, let's say, you are recording maybe sensor reading. I don't know what sensor to use, but maybe you are recording maybe sensor reading, and then you are recording it every second. If you are trying to make like within every second, there won't be any like significant change. So in that case, you can just do forward fill or backward fill because we know that there isn't going to be. Okay, I'm going to take it again. There isn't going to be so much difference within that context. So I'm explaining the forward and backward fill again. So let's say this is your data, right? This is the column that you have. This is the column, you have missing values in this data set and you want to fill it in. But then you want to do a forward fill. You don't want to use the mean, you don't want to use the median to fill it in. You just want to fill it with the number that is in front of it or the number that is behind it, right? So in this case, in the forward fill, so if this is the data set and then you have this 2 here, this 2 is going to fill in for all the null values if you declare it as a forward fill. Do we get that at least? So in that case, you are going to do it as a forward fill for everything to fill. And then if you declare it as a backward fill, it's going to start from behind and then it's going to use the 3 and fill it for everything that is there. So that's why I was saying that this is applicable. This is mostly not so advisable, but it's applicable when you are either using sensor data or temperature. So assuming that you're supposed to test your temperature every second, like let's say 1 minute or every 30 seconds. In that case, there's no significant change. There won't be so much change. Rarely will there be so much change in your temperature or in sensor readings from like in every 30 seconds. So in that, you are comfortable to use the forward flow, because you know that even if you use it, there won't be so much difference, because the number in front of it is most likely to be like maybe 0.1 or 0.2, 0.3 that will be there. So basically that is how the forward and then the backward flow works. Okay, Joseph, go ahead.
Okay, so please, you see, for this filling in the missing files,
Yes.
this method you are showing us is in the form of filling in a group form, right? What of, let's say, in a group form?
What do you mean by group?
So let's say there is some missing numbers in the missing files in the director column. So you want to fill in, so you want to use something to fill in that missing
Yes.
files.
Yeah.
So you are using just one thing to fill in all the missing files. So let's say you want to use separate things. So let's say in the director column, I have a missing files, let's say like no, but I want to use different names to fill in that columns. I don't know whether you are getting
Yeah, I do get you.
Yeah.
So
How are
like,
you going to go by that one too?
so imagine it's either it's two ways. Mostly we don't even do that because you won't even like get that time to go into the data to find even the specific thing to do it. But should in case you want to do that, you might have to find probably the index or something. So we'll be looking at filtering data. So you might want to find a specific position. If you this the so let's say you see when you always have list and all those things, maybe your how do I explain this? So let's say the list is, you see how you do list stuff. Let me just put in here. Then you are trying to find this specific place, this specific position. So you might have to find this position and then replace it in there. But it's really, I've never even tried it to like do it, because the data set is so large, you not even know like where you want to put what. It's just like maybe this column, so maybe the director column you decide to put this, and then maybe the other column you decide to use a different method if you want to. But rarely will you, it's really dicey. I don't know if
Sure.
anybody has anything to it, but I would advise that you just use this, or you have to do it manually. You open it on Excel, you find the things and you fill it in, or you find a specific index that the data is in, and then you fill it up.
Sure. All
Yeah.
right, thank you.
You're welcome. So these are also for duplicates. So here you are just trying to find in duplicated things. So if I just run this, so you see that because you don't have sum, it's returning the Boolean values again. So you see there are no duplicates in the data. If there are duplicates, you can just do df.drop underscore duplicates, and then it drops all duplicates that you have, and then it just leaves the unique ones in there. And then these are just removing or modifying columns. So here we'll just I'm trying to speed up because of our time. So we have the removing or modifying column. So maybe you want, you see, sometimes there are some things that you don't need, like in our data set, we have something like the cast. There are so many casts. In this sense, you don't need it. And then you have something like description. You don't need it in this context because we are just trying to identify trends and things. So here we are going to remove cast, and then let's say the description from the data set. Because mostly there are certain things you honestly do not need in your data set. Maybe they are even indexed. They are just things that ID numbers, like sometimes maybe you have ID numbers, you have names. It's like a repetition of ID number and name. So you can decide to just remove the ID number and then deal with the names in working. So depending on the context, you might have to remove, or you want to also change column names and all of that. So in this context, they are just trying to do that. So let's say we are going to drop in the cast and then the description column. So you just do df.drop. Then then we do the column. So if you are doing 2 columns, then you are going to put in this. If you are doing 2 columns, you say column 1, column 2. If you are doing just one, you just do only 1 column. So here we want to remove the 2 columns. So just do cast. Then we have director. Then we declare the axis. And then as you can see, you see that the cast and then the what do we call it? The cast and the director column has been removed from your data set. So this is just how it works. If you want to rename a column, just follow the same syntax, and then you'll be able to. So you put in the old name, then you add in your new name DF row to rename, and then here. Sorry. So here we have the changing column types. You see, I was saying that sometimes it's not in the right format. So you would want to change it into a format that it will be recognized by Python to be used. So let's say it's a string, but it was recognized as an integer, and then you want to change it. In that case, you would use this .as type, and then you put in the type of the data type that you want it to be changed into, and this column is going to be changed into that data type. Okay, so I will just move from way, then we'll move into this the interesting part. So now we'll be doing with the filtering, grouping, and aggregation. This will probably be the last part of today, so that we would just do a simple, I don't know if we'll have time to still do the project, but we'll try, or we'll just take it home and then try our hands on it. So yeah, this is just trying to get the columns. And then we have something called value count. So value count is just trying to get, it's like trying to group and then give you the count of each thing. So assuming that you have you see this class, let's say cost of class of people. You have middle class, lower class, and then upper class. But it's been filled in all the rows. But you want to know the number of people that have upper class. You want to know the number of people that have lower class. All of that. You don't have to go in and start maybe counting or trying to put in the row to see. So you just use .value underscore count, and then it helps you to find out the various the value. So it arranges for you. So I'm just going to run it and we see how it works. So you see here, I put in type. We have this type column in here. So you see movie, TV shows. So it actually also lists the different types that we have in here, the different values we have in the column, and then it lists it out for you in here. So let's try for, let's say, country. So I can just do DF and country. I will share this notebook afterwards. So if you've not been able to maybe follow along with the codes, I will share the notebook afterwards, and then we'll all have access. So here you see it puts in everything. It shows you everything, the number of people in United States, in India, in United Kingdom, and everything. I can actually just, maybe I can, let me see, let me explore something. I think I've tried it. So you see, so with this one, you can even decide to check from the downwards part, the countries that are from down, or I can,
Oh yes, I know Basa fan where they support United. Inusa.
please stop.
Yes, it is support United.
Well, maybe I want to tell you about the other one. You support my.
So
So,
Alpha,
so who? So it means that you try to talk to all Basa fans who support.
let me see.
Alpha,
I
Alpha,
don't know.
Alpha.
Don't be all Chelsea.
Please,
I know
please
Chelsea fan
carry
where they
me
support
there.
Basa.
Alpha,
Oh, someday they
Alpha.
just like Messi.
No be say then they like Basa, then just like it.
Alpha,
Top.
Alpha.
Mhm.
Hello, Alpha, please mute your mic.
Support every problem, support Messi, right? My skill.
Can wait,
Or Chelsea fans put
Saka,
Barca
can
because of
they
2009.
mute because I don't have
That
access
people are
to
put for the group. That be all. Oh,
Alpha,
12,
Alpha,
you
please.
put a hate with you.
Hello, Alpha.
That has mean go. I mean no be cheat, but we lash you. We lash you fairly. No, was there anything wrong with
Okay,
that?
let's try to see if you guys can hear me or
See you.
something. It is okay.
You can go. You know the highlights. You should walk
Okay.
your center back.
Wait, Aka, can
Everybody
you
gets
mute
to everybody
him
defend that.
if you
Oh,
have like
yeah,
the
let's
organized?
talk.
We can just hover
Yeah,
around
we
his,
have
then I'm sure you'll be okay. Great. Okay. Sorry for that distraction. So here you can also just like, so let's say you are trying to find the top countries that have the most number of people. You can just specify it by using this head or by using, you want to find from the bottom. So this was from the bottom, the tail. So let me just change it to the tail again. So you can see that for here, we are not able to see the significance because it's just 1, 1, 1. But probably if it's different, you see that it's going to arrange from the tail. Then you see the ones that have like lesser number of people as compared to the others. Then it counts from there. You can also just change it to head to see the top people, the top countries, and then you can see that it's ascending, yeah, or descending anyways. So it shows in this way. And then this filtering of rows just helps you to, it helps you to filter certain, so I think, okay, I was trying to tell you that we'll get into the filtering of rows where you can actually find specific things. So this one, we have in this thing. So this was for this house pricing data. I'm just going to load it so that it will help us because the data set we are using is just, I'm going to load in this. Let's say house underscore data. So just kindly bear with me while I just load this data because it will be easier with our the analysis we want to do in here. I'm just going to auto complete. Then we have yes. You see the path is not right, so it didn't work. Sorry. Trying to rush now. You. Yeah, so this is it. Now we are going to change that. So you see that I'm changing the DF because that's not the data that I'm going to use for this analysis. So I'm just changing it from here to house underscore data. And then I change to house underscore data. Let me just copy and then paste so we don't have to do so much. House underscore data. House underscore data. Right, great. So now let's preview this data. House underscore data dot. So you can see this is a very simple data. It's easier to understand. So yeah, you see that we have the home price, square feet, bedrooms, and everything. Now this thing, this filtering of rows is trying to say that. So I told us about the subsetting of the data. So this square bracket is just used for subsetting data. So you're saying that in the house data data frame, look for this column inside the house data frame, and then you pick all the prices that are greater than 500,000. And then you print only those columns for me. So you see this thing, this specific thing, it's like a conditional statement that represents the conditional statement. But you're So this wrapping that we still have house data means that it should print the rows in that house data. So it should still be in the house data format, but just for rows that are greater than 300. So we should still have the columns and everything showing, but make sure that the data that we are having, the prices are not less than 500,000. Okay, Joseph, go ahead.
So please, can we classify it as a class?
What?
If a class, like a classes.
Yes, exactly. So it's you that is trying to analyze your data. So you decide whatever that you want to name it or whatever that you want to say it to use it as you get.
Okay.
Yeah. So here this price can be anything depending on what I'm looking forward to analyzing. So if I just do this, okay, I'm not having the stuff. I feel like there is no data that is so you see there's no price that has this 500,000. Let's do let's say 50,000 and see. You see. So do we get what just happened? Exactly. So because I didn't have it, because I have this wrapping in there, the column name still showed, but the rows did not show because what I defined or the condition that I gave to that thing is not available in the data set I have. So it returned only the column names, but I don't have data because what I specified, there's no data for it. We'll just move right in. This is also another way of classifying. So it's like a combination of operators, and then you use with this thing. This is the AND operator. So you are using it with this AND operator. So you are saying that in the house data, check for bedrooms that are greater than 3 and bathrooms that are greater than or equal to 2. So we know that in these operators, in these conditional operators, if I'm not mistaken, this AND operator, both sides has to satisfy. So if I define this thing, so it's like at the same time, if the bedrooms are 3, then the bathroom should be greater than or equal to 2. If not, it's not going to work. It's not going to satisfy. So in this case, it's going to return houses that have bedrooms greater than 3 and then bathrooms greater than or equal to 2. Then you see that we have it in here. So you can see from here, bedrooms are 222, bathrooms 222, you see, greater than or equal to 2. Then we have all of that in there. So basically that is it. And this is also one tricky part of Python called slicing. So slicing is basically like indexing in Python. It basically helps you locate things in your data set. So let's say that you know an initial, you know something like you're trying to find a specific position in the thing, or you're trying to just find a specific portion of the data set to be able to use to make your analysis, but you are not getting. So in this sense, you use this slicing. So in slicing, we have something we call the log and then the ilog. So the log is basically like the location, and then the ilog is like the index location of it. When I give you the notebook, you get to know all this theory stuff, but basically this is it. So this one, we are going to use this data set. So I just manually got this data so that we'll be able to use it to fit in this context. So here, we are just using this, and then we are turning it into a data frame. So you see that there are so many ways of changing like data sets into a data frame depending on what you have. So this is a list, and then you can turn the list into a data frame and then use it for whatever that you want. So here, that was what was used. So I just ran it. Then, so in this thing, if you remember your slicing, indexing, so it uses the index location. So you are trying to say from index 0 to index 4, like print all details within that range. And then when you run it, it gives you the index from index 0 to index 4. So it's just players.ilog, then 0 to 4. The only thing is that it uses the indexing. That is it. And then we have also for the column. So this declares the rows. Then we are saying that you are specifying for the columns in here. So is it column slicing means selecting a specific set of columns from the data frame while keeping all rows. So you are keeping all the rows. This is the rows that you are keeping. And then you are specifying the columns that you want to be seen. So let's see. So you see, it's just printing out the first column, but all the rows are being shown here. So it's showing the 2 columns and then the rows are being shown in there. Then here too we have the ilog, which is the ilog is still on the index location. So selecting a specific cell in a data frame if you need a single value. So Joseph, this is what I was talking about. So is it if you need a single value from a data frame, you can specify the exact row and column position. So you don't want to go through all those checks. Imagine if you already know this position. Like, I mean, unless you're just trying to guess to find the exact thing that you are looking for. But it will be very tedious to go through this to just fill in missing values when you can just using other methods that will help you get the right values to put in there. So if I do df2, you see it prints in that specific value that is in there, in that position. So this is like column 2, row 3 sort of thing. So it finds that exact index and then it gives it to you. Then using Boolean, so this is just like using the Boolean operators as we tried in the filtering and then combining it with the ilog to find. So you see, instead of selecting rows by index, we can use Boolean conditions. So age greater than this to filter rows dynamically. So this ilog and log thing is just to help you locate stuff, like just helping you locate things in your data. Then it helps you get more insights into it. I'm not going to talk so much about the log because it's basically the same thing, trying to so with this one you don't use index. So you see we have ilog and log. The log uses the specific in the ilog uses the index location, but in location it uses the data labels. So you are able to type it in instead of using the thing. Maybe you don't know the names of the people, and then you can just type in you don't know their index, but you know the name. So you just use the name to find the specific place that it's in. So here, this is just like location. So we are trying to find, so you can see what is showing. So it's basically location and printing from this name to this name. So it's printing all that you have between this and this, from this to this. So it prints everything and then it gives it to you. And then here, it allows you to so is it in the ilog? Why do we have errors? So it's with the salary. Let's see if salary is in small letter. Why do we have an error? Sorry, are you guys following? Sorry, I'm rushing because of our time, but thumbs up if we are still with me. Okay, thank you. So here I'm trying to just check out what's happening with this one. If you have a list key, check indexing will raise an error salary. So it's something with the salary. So let's check the data set again. Age with salary. I'm wondering why. Valid index error key, razor error. Even this. I'm really curious on why. Cause let's do something here. I'm trying to see why it's not working. But if you also figure it out, feel free to tell me. Because let's see something here. This is also giving that okay. Is it that we don't have it in there or what? What? Okay, Sharif, go ahead.
Are you supposed to be in double quotes?
In double quotes? No, that
Oh,
should not be a
that
problem.
should be the case. Okay.
Yeah, because it's just giving the what do we call it? I think maybe there was I'm really wondering why. Because mostly you would get this when you have like this type of error when it's probably the label is not spelled correctly. Okay, go ahead, Bridget, before Sharif.
Please, I see value equals df.log, and I don't know if we are still using df. I think we changed the name.
Oh, yeah,
Yeah.
true. Thank you so much. Yeah. So the name is players.
Players, yeah.
These things. Okay. Because I was wondering, we have like I was checking the name because you see that's what I was saying. So mostly this type of errors is always associated with like if you just see this, just know that it's either you have the spelling of the name wrongly or you are trying to access a different data set. So mostly this type of errors like this key type check indexing error will it's always deal with like name being wrong or you probably trying to access something from a different data set. So it's not it should work. So this one it locates v dot quali and then it tells you the salary that's here. So it prints out the salary, which is this. Then here, so let's do this first before we get into errors. Do we have price here? Price. Okay, so you see, in this, we would get the same error if we try to do it because if you check in this data frame, we don't have price. But remember that in the housing data set, we have price. So we'll use house data instead of DF in this context. So house data, I'll just copy it and then make the necessary changes all over. So now let's just separate these things so that we'll be able to see what is happening in each. So now we are trying to group like average price per location, right? So this group by, you see when we did univariate analysis, we did bivariate analysis. So in this case, you're trying to analyze between price and this, and you're trying to see the relation they have. So what's the average price per location? So it groups everything together and it gives you that price that you are looking for. Location. Let's see. We are about to end and the code is starting to give errors. So now you can see that there's no location in this data set. So what do you suggest? So let's use neighborhood rather. So just copy this. It was so difficult for me to get dirty data so that we'll be able to, it will be easier to work with. So let's just still not working. So yeah, let's check for price. How is price? So you see this, in this case, price is capital, but it's small. So just fix that. So Then now you can see, so it gives you the average price for each location. So for east, it gives you this average price, for northeast. And assuming like tomorrow when we start doing the visualizations, you can just plot this on in a chart, and then it's going to be beautiful to show you the price. It will show you the neighborhood now, then it's representing the bars to show you. Then here we are also just counting. So we are grouping locations and then the number of bedrooms. This is not going to work again, so let's just replace it. Remember, location is not in the housing data set that we have. Okay. Sorry, Sharif, go ahead. Oh, you wanted to correct me?
Yeah.
Oh, okay. Yeah, so you see how this is like this doesn't make any sense. I mean, like, so now we have east, and then it's showing you the bedrooms, 2, 3, this. Then this is just like an index. This doesn't represent anything. But this is a very bad way because it doesn't make any insight. So it's like in the east. So in the east, these are probably we can try to make insight, but this shows that in the east, we have 2, 3, 5, 4 bedrooms. So these are the bedrooms that you will find in east location. Do you get? So these ones are not like incremental. So the housing represent the bedroom houses. So 2-bedroom house, 3-bedroom house, 4. So it means that when you go to the east, the room sizes are from 2-bedroom, 3-bedroom, 4-bedroom, 5-bedroom. Then in the north, we have 2-bedroom, 3-bedroom, 4-bedroom. So you see that in the north, there's no house that has 5-bedroom. And then in the west, you see 2, 3, 4, 5 in there. So basically that is this one. This 0 is just indexing. And then we would run. So I'll just replace it with the housing data again. So sorry, I'm rushing. The time is so fast spent. I'll just copy this neighborhood name. Then I will replace it for the location. Okay. So I'll just type it. And then the price, remember price is capital. Let's check if the square feet is in capital or it's in lower format. So you can see that it's not the same. It's a mixture of capital and lowercase letters. So I have to be mindful of that. So if I bring it here, I have to make the changes. So I'll change this to this. Then now let's run it and see. Yeah. Neighborhood is not spelled right, I'm sure. So still neighborhood. Oh gosh. Yep, so you can see what just happened. So in here, for each of the neighborhoods, it finds the mean, it finds the max, and then it finds the sum. So you see this thing. So you see, this is like a combination of group by and aggregate. So aggregate, like it helps you put things in sections. So just as the name, so it helps you put it in section. So you see that it's saying that group it, so you're grouping by neighborhood, but then you are trying to aggregate it in terms of price and then square feet. And then for the price, you are trying to find the mean and then the maximum value in each of those price and then the square feet, right? So yeah, so for price, you're finding the mean and then the max. And then for square feet, you're finding the sum. So assuming, let's see, let me try to put in something here. So I am trying to add in more things to it. So I'm trying to add, let's say, Bye. Let's see. It's always good to experiment with your code. So you see, so this one helps you. So the group by helps you to compare within like two features, but the aggregate helps you to put it in sections, in different sections. So depending on what you want it to look like, there are so many functions of group bind and aggregate because it's like the major part of data analysis. And then this is just to feature engineering. It helps you to create new columns. So assuming, so you see price per square meter. So you are trying to find that, okay, for each square meter, what is the value of a square meter? Do you understand? So in this case, let's say maybe in a supermarket, in your data set, you have the unit price, and then you have the total quantity, but you don't have the total sale. You would want to create a new column to find a total sale such that you'll be able to use it in computing, in finding the total sales. So in that sense, you just do DF and then you change, you give the name of the new column. So this is you see I was saying that this is subsetting, but in this case you don't even have this there, but you are defining it by something. So for you to create the new column, you set the DF and then you put in the name of the new column, and then you put in what you want it to do, whether you want it to add, you want it to divide, you want it to be a modulus, whatever that you want it to be, then you put it in there. Let me just put in this, and then this will be the last, and then we go. So sorry for keeping you guys. So here, okay, price. I know why. So now when I do house data again, I'm trying to preview house data again. So you see that we now have a new column called price per square feet. So basically this is like no, like analysis. So you've been, if I take this thing, I can be able to see something about the data that I've been given. I can be able to see the top people, maybe the top countries that have the highest prices. I can be able to talk so much about the data. And then even if it's like visuals, if I take this notebook, I'll be able to write a report on what this data entailed, the various data that we analyzed. It had duplicates, you cleaned it, you were able to, and actually, like, the surprising thing is that this is like a whole job for somebody. There are people that, most data analysts, this is like major part of your work will be doing this. So I think this would bring us to the end of today's session. We are so sorry for going overboard. I am just going to, I had a mini project, but because of our time, we'll not be able to go through it. So I'm going to share this. I hope, I'm just going to create a new document and then copy the thing. I have the data set and everything that then we can just do it at our leisure. If you have any questions, just reach out to me. I think I was tagged on the group, so you can just send me a DM. Then you ask me the question that you have. I'm just going to share this with everybody. Okay. So I have sent this thing, this simple thing that I did to help us practice, but because of the time we couldn't go through it. But I hope that you are able to you were able to get something from today's session, and then we continue with visualization tomorrow. Tomorrow will be more fun because we will be plotting and then trying to understand graphs and all. But I hope you're able to get something out of today's session. Hopefully next time. Tomorrow the meeting will be a bit shorter than today. It was very long today just because it was a bit, but I hope we're able to learn something. And feel free to reach out to me. I'll also send some notes, some resources tomorrow at the end so that we'll be able to go on and build for it, because this is like just the basic. We've not even been able to build on it. So thank you so much. I would hand it over back to Wait, the moderator for us, Mariam. Thank you so much for having me today.
Thank you so much, Benes. Thank you for your time. Guys, I hope we learned a lot today. I believe that now we all can manipulate data to draw insights. So, Benes, thank you very much for your time. We can't wait for tomorrow's session to finally visualize what we've done today. So, guys, same time tomorrow, 2 p.m. Tell your friends to tell their friends to join us tomorrow. So see you guys tomorrow. Bye.
Bye.